As we look at this video, we're going to take a look at sections 4.3, 4.4, and 4.5 all combined. And the idea here is that we're going to kind of throw everything at you at once, let you digest it, and then we'll spend a few days in class kind of going through these and making sure that you feel pretty confident. Two of these should look pretty familiar. So what we're looking at in these three sections are shortcuts for proving that triangles are congruent. Okay, just like we've had similarity shortcuts, now we have congruent shortcuts. We have SSS, SAS, ASA, AAS, and HL. So obviously there's a couple more here than you had with similarity, but still the same concept. So the first one is side-side-side congruence postulate. Okay, and this one is very straightforward. Okay, all it says is that if three sides of one triangle are congruent to three sides of another, then the two triangles have to be congruent to each other. So in other words, if I give you two triangles here, ABC and RST, clearly AB and SR are congruent, BC, ST are congruent, and AC and RT are congruent. Therefore, the triangles are congruent by SSS. So AB is congruent to RS, BC is congruent to ST, and CA is congruent to TR. Okay. So what that means is that triangle ABC, and again, make sure your corresponding pieces match up, is congruent now to triangle RST. And you would just say SSS. Okay. So there's side, side, side. So example 1 says decide whether the congruent statement is true. Explain your reasoning. So if this is what I'm looking at, well then that means that JK corresponds to MK. JK and MK, check, those are congruent, 8 and 8. KL is congruent, or is corresponding with KL. Well again, this is the reflexive property. KL happens to be a part of both triangles. So clearly it's congruent to itself. And then I think it's pretty obvious here that JL and ML are congruent. So you would say yes, and all you would say is side, side, side. All corresponding sides are congruent, therefore the two triangles must be congruent. Okay, RST congruent to TVW. Alright, so I know this side is congruent to this side is congruent to this side. Not sure about these two. So then I ask myself, well, is there any way to determine whether or not those two are definitely congruent? And the answer is no. Okay? Just because two sides of a triangle are congruent to two sides of another does not mean the third one has to be congruent. So you would just say not enough info. All right, again, I've already mentioned the reflexive property, but if a side is being shared by two figures, we say that they are congruent by the reflexive property. Again, it says see example 1A above. You're going to see that reflexive property quite a bit throughout these few sections. All right, so just be prepared for it. So example 2 says which sides are congruent in each figure due to the reflexive property. So again, NL is in both, so you'd say NL is congruent to NL. Okay, over here in the second diagram, WY is the reflexive, is the segment being used in both figures. Okay, and then example 3 says, are the two triangles above congruent? Name the triangle congruent. So if I look in the first part here, okay, so I'm looking over here now, I see that, okay, these are congruent to themselves, KN is congruent to LM, and NM is congruent to KL. Check. 3 sets of corresponding congruent sides, so they have to be congruent to each other. So when I name the first one, LKN, you got to make sure you match up here. So LK is congruent to NM, so the next one's going to have to be NML. NML. I believe that's right. Let's just make sure here. Yep. You just have to, you know, your N and L should match up, so LN, LN, we're good. Okay. And the second one, again, those are congruent. 6, 6, 9, 9, reflexive property. And so you'd say triangle XWY is congruent to triangle ZWY. All right, so again, reflexive property, and again, you'll see that throughout this section. Okay, so a couple terminologies that we need to be familiar with, and we've already talked about this a little bit, but the angle formed by two sides in a triangle is called the included angle. So for example, if I'm looking at the bottom side here and the height, the included angle is this guy right here. It's the one in between them. Okay, and the included side, it's the same argument. So the included side now is the side that's shared by two angles. So if I'm looking at this angle and this angle, the side there that's shared is this one here. That side hits both of those angles. So in these theorems, when you see included side or included angle, that's what we're talking about. So the side angle side postulate says if two sides and the included angle of one triangle are congruent to two sides and the included angle of a second triangle, the two triangles are congruent. Again, we've already seen this when it comes to similarity. So side RS is congruent to side UV. Angle R is congruent to angle U. And side RT is congruent to side UW. Therefore, the two triangles are congruent, so RST is congruent to UVW. Side angle side congruence postulate. Hypotenuse leg. Notice the only type of triangle you have a hypotenuse in is a right triangle. So HL is only used in right triangles. Okay, and that does not mean that no matter what, if there's a right triangle, that you're going to use HL. It just means that you can possibly use HL if it's a right triangle. So if the hypotenuse and a leg of a right triangle are congruent to the hypotenuse and a leg of a second triangle, then the two triangles are congruent. This follows from the Pythagorean theorem, which you should already know. If you were to plug these two lengths into the Pythagorean theorem and then plug these two in, since they're all equal, the third side's automatically going to work out to be congruent. Okay, and that's why HL always works. So here, without knowing this, you identify, hey, they're both right triangles, check. Hypotenuse, congruent, check. One leg, congruent, check. We can use HL. Triangle ABC is congruent to triangle DEF by the hypotenuse leg shortcut. That one's probably a little bit obscure, okay, a little bit harder to understand. Angle side angle. If two angles in the included side of one triangle are congruent to two angles in the included side of a second triangle, then the two triangles are congruent. So similar to side angle side, but obviously just kind of reversing things. So if angle A is congruent to angle D, side AC is congruent to side DF, and angle C is congruent to angle F, then the two triangles ABC and DEF are congruent because of the angle side angle congruence postulate. And again, we'll see all these in action as we get to work in class a little bit, okay, and we'll kind of sort things out. And finally, the last shortcut is angle side. Okay, if two angles in a non-included side of one triangle are congruent to two angles and the corresponding non-included side of a second triangle, then the two triangles are congruent. Alright, so in other words, here's your diagram. Angle A is congruent to angle D, angle C is congruent to angle F, and side BC is congruent to side EF. Therefore, triangle ABC is congruent to triangle DEF, and that's the angle side. Just go right in order. Angle, side, angle, side. Check. Alright, so let's go ahead and take a look at these shortcuts now. First of all, list the 5 ways. You have SSS, SAS, HL, ASA, and AAS. Alright, so those are the only 5 shortcuts you have. So don't make up anything. That's it. Okay, and we're going to do more proofs in class. Okay, right now we're just going to look at the diagram to determine whether or not they are congruent and what shortcut we would use. It says decide whether enough information is given to prove that the triangles below are congruent using one of the congruence postulates. Okay, I look at A. One set of sides, two set of sides, reflexive property. Yes, SSS. Part B. Okay, first thing I see is, hey, I have right triangles. I notice that OR and MN are congruent. Those are the hypotenuses of their corresponding, of their respective triangles. We have the reflexive property, ON congruent to ON. Therefore, these are congruent by hypotenuse leg. Part C, Okay, so I see one set of congruent sides, another set of congruent sides, and a set of congruent angles. So if you look at it, it's side, angle, side. All right, and since all the corresponding pieces are congruent, I can say yes because of SAS. Part D, angle, side, angle, angle, side, angle. The corresponding angles are congruent. Corresponding sides are congruent. Check. This is the ASA shortcut. And again, what we'll look at more is actually proving them. Okay. Part E, right away, my hope is that you recognize reflexive property. Okay. And now I look at this, and some of you might say, yes, they're congruent. All I know right now is this angle is congruent to this angle, and this side is congruent to itself. So I'm going to say not enough info. There's not enough information there, okay, to tell whether or not they're congruent. I look at F. Again, I would get in the habit of marking the diagram with any properties that you see right away. So in other words, I see vertical angles right away. And so now I look at these two triangles. I say, okay, U is congruent to T. SN is congruent to HS. I kind of covered up that little tick mark there. And then you have vertical angles. So if I look in this triangle, it's angle, angle, side, angle, angle, side. Check. Okay. They are congruent. Part G, again, same idea. I have angle, angle, side, 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 side. So your original thought might be, oh yeah, that's ASS. Okay. Remember, we only have 5 shortcuts. Okay, and ASS is not one of them. Okay. If ASS were one of the shortcuts, I have zero doubt that every single one of you would remember it. Okay, so it is not a shortcut, and so in this particular problem, we'd have to say not enough information because I don't know anything else there. I don't have any vertical angles or parallel lines or anything that I can use. In part H, again, hopefully right away you see reflexive property. Mark that thing right away, and then just look at each picture. Okay, I see these sides are congruent, angles are congruent, sides congruent. SAS, SAS, check. I could use SAS here. All right. So again, I know in this video we didn't actually go through and formalize any proofs. We will do that in class. Okay. And so mainly what I wanted you to get out of this video is know what the 5 shortcuts are, and then understand how you would recognize when to use which one. Okay. And so, as always, we'll build on this video in class and handle any questions that you might have.